we'll go ahead and start. You need your calculators. If you got your calculators, this first systems of equations is make sure you can do it on your calculator. But I'm going to show you how to do it algebraically also. Solving systems of equations basically means you have two equations or three equations, and you've got to solve to find out where they intersect. Okay? Where they intersect. That's what chapter 7 is. Systems of equations. Where they intersect. If they intersect, that means, okay, good. That means they have an intersection point. I'm not going to go through all of this. Okay? That's what, right over there on the right, that is a system of equations, and they have a solution. The solution is where they what? Intersect.
Intersect.
If they don't intersect, they're parallel lines. That means they do not have a solution. So you would put no solution. If they are the same line, then you have infinite solutions, or all real numbers. So there's two instances to where you will not have an answer as far as a number. You're going to have, if it's parallel lines, then you're going to have no solution because they do not intersect. And if they are the same line, you're going to have all real numbers or infinite solutions. And I'm talking 90% of the time you're going to have an intersection point. 10% of the time it's going to be parallel or the same line. So most of the time you're going to get an answer. Okay? Now there's three ways to solve it. One, you can graph it on a calculator and find the intersection point. Two, you can graph it by hand and find the intersection point. And three, you can set them equal to each other. Okay? Set each other equal to y, and then set them equal to each other. That's what I usually do and that's the best way because in calculus, you're going to be asked to do that a lot. Okay? So if you graph those two, you're going to get this line in blue, you're going to get this line, and where it intersects. What does that mean? That means if you plug 0 and -2 into these two equations, you're going to get 2 is equal to 2, and you're going to get -2 is equal to 2. They work in both, okay, and gives you a true statement in both. Parallel lines, no solution. Now make sure you say the system is inconsistent and the equations are independent. Write that down and highlight it because on some standardized tests, they don't do anything but ask you this. Is the system inconsistent or consistent? If they are inconsistent or consistent, are they independent or dependent? That's all they ask. And really all that's a bunch of junk. Okay? Basically, if most algebra teachers are going to ask you, does it intersect, or is it parallel, or is it the same line? Okay? So again, if you do it in your calculator, if you set them equal to each other, you're going to get something like 5 is equal to 6. And if you get 5 is equal to 6, you know that's untrue. So the answer is what? The circle with the slash through it. What does that mean?
The null set.
Null set or no solution. And the last one is there's the same line. These two right here don't look like the same line, but if you solve it for y, you come up with the same line. And when you have the same line, if you set them equal to each other, you're going to get a true statement, which is 5 is equal to 5. Or 4 is equal to 4. And that means your answer is all real what? All real numbers. And this is consistent and dependent. That's the highlighted words you need to write down when it's the same line or you get a true statement. It is consistent and the equations are dependent. You can say all real numbers. You can say infinite many solutions. So if I plug in 0 for x and 4 for y, they're going to work in both. If I plug in -3 and 0, I'm going to get the same answer I'm going to get the true statement. So it doesn't matter what number you plug in. It's going to work. So there's the three types of answers you're going to get. A numerical answer, which means an intersection point, or parallel lines, which means no intersection point, or the same line, which these are, if you'll get, and that's all real numbers, or infinite. So those are the three types. Again, 90% of the time you're going to get a intersection, and then 10 to 20% of the time you might get a same line, or you might get a parallel line. Okay. And what do you do when you do it? First of all, solve for y. Now, why do you solve for y? Because that's what you type in your calculator. That's how you graph, and you can set them equal to each other. So in this equation, the first thing I'm going to do is solve for y. So 3x plus 2y is equal to 11, and 2y is equal to negative 3x plus 11, divide by 2, divide by 2, divide by 2, y is equal to negative 3 halves x plus 11 halves. All right, so that's one line. And then the other line, negative x plus y is equal to 3. Y is equal to x plus 3. And that's done. Now, you can graph these two lines and find the intersection point in the calculator. You can graph them by hand, or I'm going to set them equal to each other. And the reason I'm going to set them equal to each other is in calculus, that's what you do, because you have lines that are curves and lines that are not curves. And the best thing to do is just set them equal to each other. So, negative 3 halves x plus 11 halves is equal to x plus 3. The first thing I'm going to do is multiply everything by what? Common denominator to clear the fractions. So that'll be a negative 3x plus 11 is equal to 2x plus what?
6.
6. And now I'm going to bring the smallest bucket, I'm going to bring it over, and that's going to be 3x. And I'm going to bring the 6 over, that's a minus 6. And that's going to give me 3x, or what is 2x plus 3x? 5x is equal to what? 11 minus 6 is?
5.
So x is equal to what?
1.
So how do I get y if I've got x is equal to 1? Back substitute.
Okay.
And back substitute, I get y is equal to 1 plus 3, which y is equal to 4. So these two lines intersect at what? 1, comma 4. Now I want you to graph it in your graphing calculator and see if it crosses at 1 and 4. I'm going to pull up my calculator. Man, I'm going to have to get off of this right quick, so just hold on. And pull up my calculator. Y is equal to negative parentheses 3 divided by 2 close parentheses x plus parentheses 11 divided by 2 close parentheses. And I'm going to go down to the next one, and I'm going to change it to a dotted line. And I'm going to call this one x plus 3. And graph. There's the first one, and there's the second one. Now I'm going to go to second, calculate or trace, and hit what? Intersect. And that's where you hit the first one and the second one. You just hit enter. It asks you, or you want the first line and the second line. And then after you hit enter, it's going to say, where's the guess? So the reason you use guess, there it is right there, is to kind of narrow the calculations down to one point so the calculator don't have to take time doing the whole thing. So you put the guess right about there and hit enter. And there is your intersection, 1 and 4. Now you can do that by hand, but we're not going to do it by hand because there's 2 ways you can do it. I would suggest learn how to do it algebraically because that is what you're going to use in calculus. So, I mean, you can use your calculator in calculus, but most of the time it's easier just to do it by hand. Okay? So that's solving systems of equations by graphing. Pretty simple. Either you can do it on the calculator or you can do it by hand. And let's see what they got. And they solved for y just like I did. They got x is equal to 1 and they back substituted. And y is equal to 4. So that's how you do solving systems by graphing. Now, what if you had if you had the same line or if you had parallel lines? Then you would get no solution, or you would get all real numbers or no solution respectively. Okay? And here's one with the graphing calculator. There's the 2 numbers. So what would you do? You'd put it in the graphing calculator. So, can I pull up the handy dandy calculator from here? Nope. So you would type in those, and I don't know, this thing's going crazy now. And there it is. And of course you would hit solution set. I don't deal with the table, so I would hit second function, second function trace, which is calculate, and intersection, and then hit enter, and then put a guess right about there and hit enter, and it should give you 1 and 4. Okay? So that's how you graph. And like I say, most of you have done that before, either with graphing calculator or by hand. So I'm not going to spend a lot of time on that. Now, elimination. This is the second way. And some of you that have had Algebra 1 and Algebra 2 may remember this. But remember, there's 3 rules that I say for students. 1, look for opposite signs. Look for equal coefficients. Number 3, if not, 1 and 2 make it so. All right, so first of all, do we have opposite signs anywhere?
Yes.
Where?
The y values.
Okay, so I'm going to focus on those. You don't have to, but I'll follow the KISS method. And what is the KISS method? Keep it simple. If you want to do the whips and chains and you want to put a negative with 3x and the 2x a positive and you want to work with the x's and they're not opposite signs, knock yourself out. But I'm going to use the simple method. I'm going to go with the positive and the negative. All right? So that's done. Do we have the same coefficients? No, we do not.
No.
Why? Because we have a 4 and a 3, so that's not going to help us. So what we're going to have to do is I'm going to take since I do not have, I'm going to take my blue marker here. Okay, this thing's going crazy. I don't have equal coefficients. So I've got to go down to here and I've got to make number 2, I've got to make it so. All right? So I've got to multiply the top by 3 and the bottom by what? 4. Now the reason I do that is because I want the y term to do what? I want it to what?
Cancel.
Eliminate.
Thank you. So 9x minus what? 12y is equal to 3. 8x plus 12y is equal to 48. And now we add both of those together. And of course we get 917x. And what happens to the y's? What's supposed to happen to them?
They'll cancel out.
They what?
Cancel each other out.
Eliminate.
They what?
Oh, eliminate.
I'm trying to say eliminate as many times as I can, so that way when the test says eliminate, you don't sit there and go, I don't know what eliminate means. So the 12 y's cancel, and you're left with 0.
Eliminate.
Eliminate, yeah, that's good. That's good. You sit over there in the corner. 48 and 3 is 1. Eliminate.
Eliminate.
5 minutes later, eliminate. All right, so divide by 17. Divide by 17. And you get some funky number over here, but that's okay. So x is equal to 51 over 17. All right? So
Which
now
is equal to 3.
It equals 3.
What?
3.
Oh,
It
is that,
equals 3.
Okay, I didn't know. Thank you. All right. So what am I going to do with that 3? Back
Put
substitute.
it in one of the 2 equations.
Back substitute. You put in either one. I don't care. Since the 2x and 3y is smaller, I'm going to plug it into that. So 2 times 3 plus 3y is equal to 12. 6 takes that to a 6. 3y is equal to 6. Y is equal to what?
2.
So these two lines cross at 3, comma what?
2.
And you can check that by setting them equal to each other, or you can check it by putting them into the graphing calculator. And that's how you do elimination.
That's hard.
Well, somebody will make it hard, let me tell you. It's not hard. Let me get to, I don't know what's wrong with this thing. There we go. And I don't know what they're going to get rid of. They got rid of the 6. Well, see, I disagree with that, because why would you get rid of something that doesn't have opposite signs? That's just another step. So they multiplied the top by -2 and the bottom by a positive, what, 3? Yeah. And they got 2. See, we got 2 also. And back substitute, and they got 3. So that equation, those two equations cross at 3, 2. And that's elimination. Okay, here is inconsistent. What does inconsistent means? Parallel lines. All right, now what's going to happen is, I'm not going to do it by hand, because what's going to happen is, you're going to get 5 is equal to 8, or -1/2 is equal to 33, or 4 is equal to 2. You're going to get something that's untrue. All right, so there. What'd they get? 0 is equal to 15. If you get something like that, and you have done everything what? Correctly,
Right.
then you have parallel lines. Parallel lines mean they do not what? Intersect. If they do not intersect, then they don't have a what? They do not have a solution. What? Well, that's all right.
I'm just gonna make somebody allergic.
Yeah, everybody's going to be allergic to them. Okay? And that's what the graph looks like. Parallel lines. Now, okay, dependent. Okay, what's going to happen here? You're going to get a true statement or an untrue statement? A true statement, because the last one was untrue. So this one's going to come up with 5 is equal to 5, or -1 is equal to -1, or x plus y is equal to x plus y. You're going to get something that's true. And you do the elimination, and you get 0 is equal to 0. If you get 0 is equal to 0, that means they're the same line. They're laying on top of each other. So that means what? All what? It's intersecting
all real
everywhere.
numbers.
So that means all real numbers. Okay? Is this where they, I don't know what they're, okay, I don't know what the heck they're doing there. I want to do the substitution next. Well, I'm sorry. Notre Dame is going to win it all. Notre Dame and Oklahoma, they're going to win it all. I'm not even going to talk about it. There's substitution. All right, substitution. What do you do with substitution? This is the third method. There's 3 methods of solving systems of equations. 1, graphing. 2, elimination. 3, substitution. Find something to solve for y real easy. Well, there's not really anything, so I'm going to take this one. Why am I going to take this one and solve it for y? Because it's an easier what? It's an easier equation than that quadratic. So I'm going to solve for y. 3y is equal to -x minus what? 4. Divide by 3, divide by 3, divide by 3. Y is equal to -x over 3, or 1/3 x, -1/3 x, minus 4/3. Or I can say, -x minus 4 over 3. I can say that. Either way, I don't care which one you use. Okay, this one is a little bit easier to work with, but however you want to write it. Now, what am I going to do with that y? Since that's equal to y, what am I going to do with it with the other equation? I'm going to substitute this in for y. So that's going to be 3x squared minus 2 parentheses -x minus 4 over 3 is equal to 5. And that's going to be 3x squared. And it's going to be a mess. It's going to be -2/3 times -x minus 4. I just brought the 1/3 out. That's 1/3. I just put it out here. Now I'm going to distribute it. 3x squared is minus, it's going to be plus 2/3 what? 2/3 x plus what? Plus 8/3 is equal to 5. I want to get rid of the what? What do I want to get rid of? So I got to multiply through by what? 3? I'm going to put a multiply by 3 right here. And that's going to give me, well, I'll get there in a minute. It's computer, I did something. I don't know if I opened up a program or whatever, but it's been blinking ever since. 9x squared plus 2x plus 8 is equal to what? 15? Now bring that 15 over, and that's going to be 9x x squared plus 2x. And what's 8 minus 15? So be a minus 7. Minus 7 is equal to 0. And solve that, and you see where they... now, another way to solve this is to set them equal to what? Each other. You would actually have to solve for y or x or whatever you want to solve for and set them equal to each other. But now you've got a quadratic that you can solve using the what? Completing the square and finish it out.
Hubert,
Yes.
why did you not just put the x values in the x value of the bottom fraction into the top one? Put everything else on the right side and just put that into the x values on the top so that you don't have to deal with all those fractions.
You could have done x, or you could have done that also. Either way, I just picked y. So
Okay.
you can do that also. You can say x is equal to negative 3y minus 4 and plug that in for x. That's a good observation. You can. The main thing is that you understand that you're substituting versus elimination. Okay? So I'm going to erase this whole thing. Well, there. And she said solve for x. So x is equal to negative 3y minus what? And take that and do what? Substitute right there. You're just going to have shortcut number 2. So 3 times negative 3y minus 4 quantity squared minus 2y is equal to what? 5. And that's going to be shortcut number what? Number 2, Hubert. So 3 times, okay, that's going to be 9y squared. 9y squared. And then 2 times negative 3 times negative 4 is going to be 24. Somebody help me out. Plus 24y plus 16 minus 2y is equal to 5. Now, of course, if you suck at shortcuts and refuse to learn them, then you don't know what I did there. So 27y squared plus, what is that, 72, help me out, plus 48 minus 2y is equal to 5. You thought you were going to save some work, didn't you, Miss Shuttleworth? You still going to work. It's kind of the age-old, you're not going to get out of it. I know, I'm a racist. 72y minus 2y is what? 70y plus 48 is equal to what? 5. So 27y squared plus 70y. What's 48 minus 5? 43? Is equal to 0. And of course, you would start by using your quadratic formula to solve that one. Now, the good news is I probably am not going to give you any of these on the test. I'm going to give you one that's real simple. What I mean? Well, I'll show you. Let me get out of this thing, because this thing is, I don't know what it's doing, but the blinking is getting on my nerves. Okay? They solved for y, Miss Shuttleworth.
It's just a suggestion.
No, you thought you were better than me. You're racist.
Oh.
Okay, so I'm going to get out of this, and I'm going to get out of this, And I'm going to get out of this, load, and I'm going to hit whiteboard. And this is the problem that I will give you on the test. I'll even solve it for you, you know, so you won't have to solve, but yeah, I'm gonna give you the whole thing. X plus Y is equal to 4, and 2x minus 4y is equal to 6. Okay, now what am I going to solve for? Am I going to solve this one, or am I going to solve this one for a pair?
I'm gonna go with
This one.
that one.
All right, so I'm going to solve for y because that's what we're taught to do all the time. You can solve for x like some people that want to go against the grain. You can solve for x, but y is what I'm going to solve for. Y is equal to negative x plus what? Now what am I going to do with that negative x plus 4? It's not blinking anymore, is it? It is?
Look at the board. It's every time you touch it.
Well, yeah, it does that, yes, but it's not blinking like over here. It's not blinking back and forth.
Oh, keep shutting off and come back on.
I think so. All right, so I'm going to take this right here, and I'm going to plug it in for what?
Why?
For y, because it's equal to y. So I'm going to go over here, and I'm going to say 2x minus 4 times equals 6, and I'm going to plug that negative x plus 4 in there. Distribute my negative 4, and that's going to give me 2x. What's negative 4 times negative x?
That's a positive.
Okay,
Positive
and
4x.
negative 4 times negative 4,
Negative.
and now solve. What's 4 plus 6x? 4 plus 2x? 6x.
6x.
16. And then bring the 16 over. 6x is equal to, what's 6 plus 16?
22.
Divide by 6. X is equal to 11 over 3. So what am I going to do with that 11 over 3?
One in the
11 over 3 plus 4. Oh, you're going to quit here because you don't know how to do it. Negative 11 over 3 plus 12 over 3 is equal to what? So where does these two lines cross? At 11/3 and what? 1/3.
1/3.
That's the kind of substitution I'll give you on the test. Which the test is open and you can take it.
When's it due?
Probably 3 weeks from today.
Oh, wow.
Yeah, grade turn-in is in a week or two,
Alright.
but yeah.
Oh.
Don't turn it in 3 weeks.
Yeah.
He's lying to you.
Gosh. All right.
I kind of look out for my
All right, there's 3 type questions. 1, graphing. 2, substitution. 3, elimination. And there's one more. And that is a 3 by 3.
Oh my God.
And the reason I'm showing you a 3 by 3 is because you might see it in the future. Okay? You sure?
I don't have a future.
Yeah, you don't. Losers don't have futures. All right, let me go to a handy dandy. I think I'm in 7.2. I think that is when we're talking about. So I just want to get an example. Okay? Let me go down here and get an example. Oh, let's talk about 3 dimensions. That's what you're doing. Okay.
Oh, my word.
There it is right there. I'm just going to pull the example out and go to slideshow, primary. Okay. There's my question. Now put this in your notebook. I don't think I put any of these on the test, but if I did, I'm going to show you how to do them.
You did say you was going to fail.
The first, yeah, I did. the first thing you're going to do is you're going to pick number 1 and number 2, and number 1 and number 3. Now you can pick 2 and 1, 2 and 3, 3 and 1, 3 and 2, but one of them has to be represented twice. Okay, so I'm going to pick these 2 and these 2. And I'm going to put over here 3x plus 9y plus 6z is equal to what? 3. And 2x plus 1y minus 1z is equal to 2. And then I'm going to go over here and I'm just going to change colors and I'm going to write these 2 down. So 3x plus 9y plus 6z is equal to 3. And 1x plus 1y plus 1z is equal to 2. Everybody see what I did? I just picked. Now, you don't have to pick 1 and 2, 1 and 3. You can pick 2 and 1, and then you pick 2 and 3. I'll just go over here. You can pick this one, and you can pick this one and this one. You can pick this one and this one. I mean, this one and this one, or you can pick this one and this one. Just so long as one of them is represented how many times? Twice. Here, once, and here. It has to be in both, and there's no other way to do it. When you pick 2, you're going to have 1 repeated. Okay, there's no way to get out of it. So really, there's no way to screw this up. There's always one way for somebody to screw it up, but in this case, there. Now what do you do? Well, you want to pick something to get rid of. Okay, which one is it? 2x, y. All right, you want to pick something to get rid of. I'm going to pick z. Why am I picking z?
It's opposite.
Because the opposite signs. There's the only opposite signs I've got. So I'm going to, now you can get rid of the most, you can pick the 9 and the 1 if you want to get, into the punishment. Yeah, that's fine. Go ahead and knock yourself out. But I'm going to get rid of the opposite signs. Now, whatever I get rid of in 1, I have to what? I have to get rid of at the other. I can't just switch. So I'm going to get rid of, y'all have to excuse me, I've kind of picked the wrong color. I'm going to get rid of the z's. And if I get rid of the z's in this section, I got to get rid of the z's in this section. You can't mix. You can't say, well, I get rid of the z's over here and I'm going to get rid of the y's over here. You can't do that. That's changing horses in what?
Midstream.
And you can't do that. All right? Don't change horses in midstream. If you're doing something, you don't change your process in the middle of doing something unless you're doing something wrong. You might want to change. But, so I'm going to take my handy dandy red pen and I'm going to multiply this bottom by what? 6. And over here, I'm going to multiply this bottom over here by negative 6. So, over here I'm going to get 3x plus 9y plus 6z is equal to 3. And what's the bottom? 12x plus 6y minus 6z equals 12. And what happens? Oh my gosh, the z's cancel out. And you're left with 15x plus what? 15y is equal to 15. Now let's go over to the blue one. So I get 3x plus 9. Plus 9y plus 6z is equal to 3. And the bottom is negative 6x minus 6y minus 6z is equal to negative what? 12. And what happens to the z's? Oh my gosh, look what we got now. We got two equations, two what? Unknowns. So now you can go back to your elimination or substitution and find out what they are. So, negative 3 minus 6, or 3 minus 6 is negative 3x. 9 minus 6 is negative what? Or positive 3y. Right?
Yeah.
And 3 minus 12 is what? Negative 9. Now you need to write those two down because I'm going to another screen here in just a second. I'm going to have to erase this. So now I've got 15x plus 15y is equal to 15, and negative 3y plus 3y, negative 3x plus 3y is equal to negative 9. I'm going to multiply the 3's by 5 because I got opposite what? X's. The opposite X's will cancel out. So I'm going to go up here and I'm going to put 15x plus 15y is equal to 15. And then in blue, negative 3x plus 3y is equal to negative 9. Now, I'm going to erase this. You know, it'd be something if I recorded this, then you could watch this over and over and, you know.
I was thinking the same thing.
I should record, shouldn't I? I should get with the other 90% of the teachers on college campuses and start recording, shouldn't I? So, I'm going to multiply the bottom by what? 5.
Right.
And when I do that, I get 15x plus 15y is equal to 15. And I'm going to turn my new one purple. And that's going to be negative 15x minus what? Minus 15y is equal to what? Positive what? 45. Uh-oh.
Is it positive or is it negative 45?
Positive 15, yeah. Positive 15 and what?
Negative 45.
Okay. And what happens to the 15x's?
They can't.
They cancel, and you're left with 30y equals negative 30, and y is equal to what? And dang on negative 1, what do you think we're going to do with that negative 1?
We'll plug it in.
Back substitute into that 3x plus 3y. So I'm going to go negative, and you can plug it into either one, negative 3x plus 3 times negative 1 is equal to negative 9. Negative 3x minus 3 is equal to negative 9. Negative 3x. What's negative 9? With that negative 3, this is a negative because it takes longer to erase. So bring that over, that's going to be a plus 3. Is what? Negative 6. X is equal to what? 2. Now I've got y and x. What am I going to do now? Plug into 2 times 2 times 2 and what? Plus what? 1 times what? Negative 1? minus z is equal to 2. And what's 2 times 2? 4. Minus 1 minus z is equal to 2. What's 4 minus 1?
3.
3 minus z is equal to 2. Minus 3, negative z is equal to negative 1. Z is equal to what?
1.
So this function crosses at 2, comma, negative 1, comma, and what? Whatever. It crosses at 2, negative 1, and 1. So these three lines cross in a three-dimensional graph at 2, negative 1, and 1. So when you go through, and I'm going to erase this now, that's why I put it on video, so y'all can pause it whenever you want to for the one person that uses it. Okay, you hit, let's see what they got. Did I get 2, negative 1, and 1?
Mm-hmm.
It's a miracle. So make sure you can do make sure you can do 3 things. Make sure you can do, 4 things. Make sure you can do graphing. Make sure you can do substitution, elimination, and make sure you can do a 3x3. But I don't think I may have put 3x3s on the test. I can't remember. But I did not put them on the final. So, okay.
Hubert.
Yes.
Do those answers have to be in any specific order?
Yeah, X, Y, and Z.
Okay.
Yeah, they have to be X, Y, and Z. Always remember that. Always, your coordinates always have to be in alphabetical order, X, Y, and Z. All right. Now, let's get to your questions. Always got somebody. Always got to ask questions. Always. Tell you what, can't come in here and just have class. Always got somebody.
I'm communicating.
You're not supposed to communicate. You're supposed to sit there like a tit on a bull. All right. That's how you get things in life, Miss Shuttleworth. You don't say nothing. Don't get me started. Oh, we gotta log in again.
Go watch that movie.
No, I ain't watched a dang movie. I had a rough weekend. Very busy on the farm. I wasn't able to do anything. So muddy. I had to take to haul cows to the sale. I had to take the tractor and hook up to the trailer and back the trailer into the holding pen. It was so muddy, my truck wouldn't pull it. It was so. I was sinking up to my rims. I mean, it was. Okay, I don't see no questions from you. Oh well. No
I know they're there.
I don't see them.
I think I only see one
with
or
all
two.
these missing LDAs. You know what this? You know what these people want? If I don't turn in attendance, they say I need to drop you. Now understand that. If I don't turn in attendance, I have to drop you.
That's why I keep getting those stupid emails.
I don't turn them in because I think it's stupid. I'm still looking. Oh, there's some more LDAs.
Wow.
Let me just look up Ask My Instructor. Or I'll just look up Shuttleworth. There she is. She's got 2 questions. Dang old Sophia. Dang old she.
Urgent.
Urgent. All right, 6-4. I've tried everything I learned and I suck. All right, let's see what this one says. Okay, this is not, well, it is a test question because it's real simple. What is it? Change base what? Can your calculator graph anything besides log base 10 and log base e? No, it cannot. So you've got to change these into change base formulas. Okay? How do you do that? Well, the change base formula says that if you have something to a different base, hold on a minute. My whiteboard is gone. Golly, what a surprise. Hold on, getting there. Y'all have to realize that I'm doing stuff that I'm not really supposed to do. You know, I'm on this campus. I'm really not supposed to do this kind of stuff. You know, technology. I'm supposed to be making posters. Innovative teaching. Make posters. All right. The log base B of A, if I want to change that to log base E or log base 10, then I do log base E of A over log base E of B, or log base 10 of A over log base 10 of B. So in other words, and this is natural log of A over natural log of B. In other words, if I have something right here that's not equal to E or not equal to 10, because these are the only ones I can calculate on the calculator, okay, then I put the big one up here and I put the little one, the base, down here, and I either take the natural log of those numbers or I take the log. So in this case, I'm going to have to use the change base formula, because what's my base on these two?
1/2.
So I can't do that in a calculator. Now, I'm an LOG teacher. I like to teach LOG, all right? Some teachers like natural log. It doesn't matter. So I'm just going to change that first one into LOG, which is log base 10, of X over, I'm sorry, hold on, of X over log base 10 of 1/2. And you would do that in a calculator. So there is your new formula right there. And the other formula is going to be G of X, and that's going to be log base 2 minus X over log of what? 1/2. So you're going to graph these two. So take your calculator and graph both of those, and that's what they're asking you to do. So I'm going to take my handy dandy graph,
Part of the issue also was this little graphing function thing on here. I cannot figure out how to get it to do what I want on here.
Okay, well, let me see what it... I really care about your calculator, but I know what you're saying. Okay, the logarithm is right here. These are logs right here. So if you take your handy dandy calculator and graph, which y'all supposed to have this in your family of graphs, y is equal to log of x, parentheses, delete, and go down here and delete there. Okay, so graph. What does that look like? It looks like this one right here. So that's pretty much where you go to graph it. That's the only thing I can see. Now you're going to have to go to your graphing calculator and graph it so you can get a point or whatever, or do it by hand and make you a little chart. But I'm going to graph y is equal to log base, or log of x over log of 1/2. So log of x divided by log of 0.5 close parentheses. And go ahead and graph that and see what it looks like. Okay, so it's going to look like, I guess, this function right here. I don't really see, I don't see really how you're going to do it. Okay, there. See? That's the logarithm. Yeah, right here. See down here? See what that says?
Mm-hmm.
Logarithm. All right, so let me do the other one also. So let's go over to the graphing calculator. My graphing calculator has now disappeared. Anybody know where it went? Now just bear with me. Go ahead and graph it on your calculator because you're going to need your calculator to graph it. There it is. So somebody tell me what the other one is before this thing blows up. It's log of what?
2 minus x.
So log of parentheses 2 minus x, close parentheses, divided by log of whatever.
1/2.
1/2. Divided by log of 0.5, close parentheses. And now you can graph both of them. And that's what it looks like. All right. Now you can go to your table, go to the table, and that's where you get your information. See here, table. Okay, so your function, the first one, starts at 0, 0. You see that? Or
Yes,
1
sir.
and 0, I'm sorry. So the first function starts at 1 and 0. So let's take our handy dandy, see if I can find this. Hold on, let me pull the homework question back up. I'm trying to figure out how to work both of these. Y'all just bear with me. Where's the, okay. There we go. All right, so the first one is going to be at 1 and 0. 1 and 0, and I'm going to click logarithmic. 1 and 0 right there. And then you're going to have to go, what does it look like? Let me hit the graph.
This is the part where I was really struggling, is trying to figure out how to type all
So
this
you're going to
stuff
have to
in.
flip it because it's going this way because of the logarithm. Well, wait a minute, yeah. Because the log of 1/2 is flipping it. So you basically are going to have to flip it. Well, wait a minute. It's going the right way, isn't it? See, I'm having to switch between, yeah, it's going the right way, see? It's right there. And then the other one, where is it? So you hit the other function. We're going to hit it again. And the other function crosses at 1 and 0 also. And then we got to put another, probably have to put another one at 2, and, well, it's got an error, so that's, oh, it goes down to 0, -1. So we can put its place at 0, negative what? 0, -1 right there. Well, it's not gonna let me do another one.
Doing the wrong one.
What?
Second same.
Oh, I might have to do 2 separate graphs. So what was 0, 1? Yeah, and hit save and hit check.
I think it only wants the second
Okay,
one.
I know what it's wanting. All right, this is what it's wanting. I've just lost the whole problem. I went to change base formula. Look, what they're wanting, I didn't see it till just now. Log base 1/2 of x and log base 1/2 of negative x plus what? What does the negative say? The negative says that I'm going to flip this thing. Okay? What does the positive 2 say? Positive 2 tells me I've got a horizontal shift of 2 to the what?
Left.
2 to the left. So you're going to draw this thing, take your calculator and put in log of negative x. Put in log of negative x and show where it goes, because what you're doing, they're not asking you to do the change base formula. I thought they were. They're asking you to just graph based on the what? The vertical and the what? Horizontal shift.
Horizontal shift.
That's all they're asking you to do. So I'm going to just do the log of x. I'm sorry, I read the question wrong. And then I'm going to do the log of negative x. Just so you can see, because you're not familiar with logarithms, so, and none of us are. I mean, none of us walk around with it, you know, in our brains. So we've got to use that as a crutch. All right, so graph. There's the first one. Now, what does the second one do? The second one comes in like what? It's the opposite, right? It's the opposite. So, if you plug these two in, you're going to get the opposite because of the negative, but the negative is going to go which way? It's going to go this way, all right? Like this. It's going to go like this, but it can't go past a certain point because you can't take the what? Right here. You can't take the logarithm of a negative. So set this equal to 0. Remember our vertical asymptotes? All right, so negative x is equal to negative 2. X cannot equal what? 2. If you plug in 2, you're going to get the logarithm of what? You're going to get the log of 0, Hubert, and you can't do that. So here, we can only go to what? We can't go to 2 because we can't use 2, so that's basically what your graph is going to look like. Now, I don't know how they ask you to do it because I'm not familiar with the question, but that's the answer right there. Basically, I turned it around. Oh, I've also got a horizontal shift of 2, so that means it's going to go left 2 places. So that means that this guy is going to end up, well, we already did it. We already did it because of the vertical asymptote. That's where it should end. Okay, that's not a test question. Shouldn't
Okay. Well, say I go home and I still can't figure out this stupid graphing function thing on the homework, and I get the problem wrong. How am I supposed to?
Then you're going to fail because of that one question. You're going to fail.
Well, it's numerous questions. I mean, I only sent you one.
Okay, well, I'll look at it in a minute. Remember, what question was it on the homework? Did we see it? Okay, let's go back and find it.
It's like 6, 7, 13, 14.
Let me look.
There's a few of them.
There it is. It's number 16. Somebody write number 16 down and I'll take that one out. This is number 21. Let's see what it looks like.
I think 17 was like that too.
Okay. 8x minus 9. Okay, first thing you're going to do is 8 to the x minus 9. It says for the exponential find f of negative 1 analytically and find both f and f of negative 1. Okay, graph. Okay. So, first of all, this is where you change everything around. So, you would write y is equal to 8 to the x minus 9. So, the first thing you're going to do is write y is equal to 8 to the x minus 9. And then x is equal to 8 to the y minus 9. X plus 9 is equal to 8 to the y. And what do you have? The definition of what? Definition of a logarithm. This is a, this is y, and this is x. And what's the definition of a logarithm? Y is equal to log base A of X. All right, what's Y? Y is Y. So Y is equal to log base what? 8 of what? Of X, right? Of X plus 9. So that's the logarithm. And of course, if you're going to do that, what is this saying? Well, 8 to the X is equal to 9. So you would go to the graph and you would punch that in. You know what that looks like. Okay, it's not going to let me put it. But you're going to graph X to the 9, and then you're going to graph log of 8, and that's what it's supposed to look like. It's supposed to look like that right there. Now, if you wanted to find out where they equal, you would set them equal to each other, and that's the intersection point right there. But I'm not going to worry too much about that, so I'll take those off. Let's go ahead and take that off. What section is this? 6.4?
Mm-hmm.
But I don't want to. Isn't that one I told you? I don't want to take all of them off. I'll just take those 2 off. That's number what? Oh God, I can't take them off because y'all have already started them. I can't take them off, so I'll just give y'all points for it. So I'll give you 3 homework points for those. And how many are there like that, Miss Shuttleworth? He said there was one more, so is there 3?
I honestly cannot remember. I've been doing nothing but math homework all weekend, so it's just like a lot in my head.
Well, I'm not going to take your word for it now.
No, I was doing it just
Okay.
like 3 hours ago.
Okay. So it's like 4 or 5?
Yeah.
All right, Mr. Bay and Miss Shuttleworth, let me know how many of those are on there, because I can't take them off because that homework is important for the ones that I wanted you to do. Let me just look at it.
Is there anything that you are going to take off? Because you said...
I've already done it. I did it before class. You have to look at it. Have you looked at it in the last 30, 40 minutes?
No, I'm not allowed to have my laptop.
Yeah, that's right. You're not allowed. So look at it after class. I took some stuff off. Not much. Hold on. Because I want y'all to suffer. There we go. All right, main menu on Math 110. And if you go to assignments, let me go to assignment. Let me go to course tools, assignment manager. That's 6.4.
Mm-hmm.
I took off 2 sections right there for you. 6.4.
Praise you, Lord.
What?
I said praise you, Lord. I've been I totally misunderstood when we were supposed to be doing the 6-point stuff. So Friday, after I turned in my big research paper for English, I have been doing nothing but math, literally.
Well, that's good. I'm very pleased.
It's been something.
All right, let me see if these are the questions I want first. Yeah, see that question, all you got to do is set the 4x plus 1 equal to 0, because you can't take the log of what? Of 0 or negative. So you set 4x plus 1, what's 4x plus 1 is equal to 0? Let me go back. I'm going to make sure the graph of the above is given with 3 points. Determine the following of graph of f of x. That's where you use your graph. What you should do is this one is put this in the calculator, 3 to the x plus 1, and then go through and do your algebra and do, that'd be y is equal to 3x plus 1. So x is equal to 3 to the y plus 1. X minus 1 is equal to 3 to the y. So I've got to change that into the logarithm and then punch that in. So that one you should be able to do that. That's number 3. Let me look at number 2. Number 2 you should be able to do.
I think it was all smooth riding right until the end.
Okay, so the first 3 were okay.
Mm-hmm.
That should be okay. This one, you set the denominator, you set the 4x plus 1 equal to 0, and whatever that number is, that'd be what? Negative what? 1/4. All right, so you have to use all numbers from negative 1/4 to what? Actually, you can't, yeah, it's inclusive. So that would be negative 1/4. And that should be the answer. Yeah. Okay, so that one's doable. Okay. 5. Find the domain. Set the negative 3x equal to what?
0.
0. Okay. Find the domain. Negative x squared. That's going to be what? Negative x squared is equal to 7. X squared, no solution because you can't take the square root of a what? Negative. So that would be no solution. Yeah. Okay, so that's doable. X squared plus 100, that's doable. Set it equal to 0. Again, that's going to be x squared is equal, negative x squared is equal to negative 100, which is x squared is equal to 100. And you can't take the natural log of a negative number, so the only answer is what? 10 and above. Because you can't take the square root of a negative 10. So it's got to be 10 or above. So that would be parentheses 10, comma, what? Infinity? Parentheses. Unless I did something wrong. What did I do something wrong? Let's see. Oh, okay, they want negative 10 and 10. Okay. But you can't. Oh, yeah, you can because negative 10 turns into a what? It turns into a positive. So it is negative 10 to 10. But that's how you do it. Next question. Set that equal to what? 0.
0.
Set that equal to 0. Set that equal to 0. Okay, so these are the ones, okay, you should be able to do that in the calculator. Calculator, then match it up. Calculator, find which one it is. Calculator. Okay. All right, so that's number 35. 35, somebody write it down. 35, 37. Now, the only reason I'm taking these off is not because they're complicated, because the graphing part is complicated on here. I want you to be able to do them in your calculator, and most of you can do it in your calculator. If they had A, B, C, or D as the answer, I would give these to you because you could match it up. But these are too complicated on the calculator. So on this is too complicated. So let me go back. 36 and 37. 36, 37, yeah. 39, go ahead and put that. So that should be 3 or 4?
3.
3?
3.
I think there's a couple more towards it.
Okay, now these you could do. Why? Because you don't have to graph.
Mm-hmm.
Actually,
What?
there's a part in tennis problem you have to graph.
Is it the graphing pick? Is it pick A, B, C, or D, or is it you have to actually graph? Okay, well let's look at it. What does this one do? Okay, explain how the graph of blah 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 can be obtained from blah blah blah. All right. So the x does not have the 4 with it, so that's a vertical shift of 4 what? Up, and it's also compressed 4. So that means if it's compressed along the x-axis, that means it's stretched along the what? The y-axis. So where is it stretched along the y-axis? It says stretch vertically and stretch vertically. So it's either A or C, and it is what?
A.
So that's doable, but let's see what the graphing does. Yeah, so you can do this one because all you got to do is put it on a calculator. But anyway, you know log of 2, we said the log looks like this. That's what the log looks like right there. And right here, that's what it looks like. But we know that it's compressed. And we know it's got a vertical shift of 4 up. So it might be this one right here. You'd have to check your calculator. I can't see if that's going down or not. Is that blue or is that?
Yes.
I think this is it. No, I can't see it. It should have a vertical shift of 4, so I'm trying to see.
Actually, I think the answer is A.
A? Okay.
Mm-hmm.
Good job, Mr. Bay. You're still going to fail. All right.
Last name's got a S on
Evaluate log base 4 of 8 analytically. Okay, they want you to change it into a what? Well, y is equal to log base A of x.
it.
8 is equal to 4 to the 10. Okay, all right. This is how they want you to do it. Well, the only thing I can see is that you're going to do x is 8, right? 8 is equal to 4 to the y power. Ain't that the definition of logarithm?
Mm-hmm.
Let's write it down. Because this is not a hard question. This is y is equal to log base 4 of 8. So what do? Well, a to the y is equal to what? 8. 2 to the second power to the y power is equal to 2 to the what? To the third. I showed y'all this problem. I told y'all would see this. Power rule, 2 to the 2y is equal to 2 to the third. And what do you do when the bases are the same? Set the exponents what?
Equal to each other.
Equal to each other. So 2y is equal to 3. Therefore, y is equal to what? 3 what? 3 halves? So 3 halves is your answer. That's doable. And that's a test question because I want you to be able to do the definition of a logarithm anyway, anyhow. We'll type it in so I can feel good about myself. 3 halves or 2/3? 3 halves. Okay, so write that one down, 51. Suppose f of x equal to log base a of x and f of 2 is equal to 6. Just write that one down. I'm not going to fool with that one. That's too tedious. Okay, I want you to do this because it says use the graphing calculator. All right, what are you going to do? Well, the first thing you're going to do is you're going to put that 4 out to the front, and then you'll have the what? Definition of what?
Logarithm.
This is a great test question. All right. First thing I'm going to do, log base 10 of x to the what power? 4th power is equal to x minus 2. This is x. This is what? I'm sorry, this is y. This is what? This is x. This is y. And this is base a. So how do you do it? What do you do? Y is equal to log base a of x is equal a to the what? Y is equal to what? X to the 4th. How do they want you to use a calculator on this? Hold on a second. I'm trying to see what they want you to do here because you can't use a calculator on.
Gotta change it around before you use calculator.
Well, I did, but that is not going to help you at all because that's going to give you the 4th root of 10 to the x minus 2 power unless they want you to use the change base formula. If I can change this stupid thing over. Let me see. what they want you to do. Do they want you to use the change-based formula?
I just guessed the answer.
Oh, they want you to just graph both of them and see where they intersect. Okay, I'm sorry. I was making it harder than it was. All right, graph log of x to the 4th power. So let's take I gotta go find my calculator again. This is a doable problem because it's on the calculator. But hopefully your calculator won't disappear from you. So here we go. Y is equal to log of x to the 4th. So you would hit log of x raised to the 4th power. And go to the right and hit parentheses. And then go down. And what's the other one? X minus 2. So type in x minus 2. And then what? Graph. And there's logarithm. And there's x minus 2 right there. And now we're going to go in. I'm going to do a zoom box. And I'm going to, this is just me. I'm going to go up here and I'm going to go over here and I'm going to hit enter. And I'm going to make my box just cover the what? The intersection points. Like there. And hit enter. So how many intersection points are there? 1,
3.
2, 3. So now you just hit second, trace, and it's going to ask you intersect. I'm going to do 1 for you. And yes, that one, and then I'm going to go down here, and I'm going to put that function right there, and it's going to be in the 3rd quadrant, so it's going to be negative and negative. So let's see. Negative 2.27, negative 2.27. So yes, and you find each one of those. So that one is doable. Next one. Use graphing utilities. Okay, so do the same thing. Graph both of those and find. I thought they were wanting you to do it algebraically. Okay, blah, blah, blah. Let me see what this one says. This one says the right side of the tower has a shape that can be approximated by the graph of the function defined by that. That's too tedious. Go ahead and mark that one, Miss. And 26, suppose blah, 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 and blah, 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 determine the function value. Okay, just mark that one too. So that's how many questions? 7. Okay, Ms. Shuttleworth, you are responsible, and Ms. Hawthorne and Mr. Bays are responsible for texting me tomorrow, or not texting me, but and to give, because I can't do it until the homework is done. And the homework is done when?
I think
okay, we need to give y'all some extra time on that. Hold on.
If you could please, I think it's done. It's due today. Even chapter 7 is due today.
Yeah, that's yeah. I meant to change that. Okay, I will do that right now. I will change everything until the 10th.
Oh,
and that
thank
way I'll
God.
give y'all plenty of time to work on it. Well, not the 10th, but because you don't need to put the homework on the same day as the test is due. So I might make it the 8th or the 9th, okay?
That's fine.
Okay,
Thank
so
you.
make sure you get it done, and it's been great. Hope y'all can take my 111 whenever I teach it or whatever. I don't know if I'm teaching it.
Yes, I'll be taking calculus.
What?
Even
Oh, I'm teaching calculus. I'm teaching calculus in the summer. So that'd be great if y'all could take the 111 this next, and then I'll be teaching it with the Polycom in the summer. So that's a good thing, okay? All right, y'all have a good day, and I'll fix this homework